Hello everyone, today we're going to look at Leetcode number 206, reverse linked list. So the problem is, given the head of a single linked list, reverse the list, return the reverse list. So we can look at example here. We have a linked list with the nodes 1, 2, 3, 4, and 5. So we want to reverse this list. That means that the last node, which is 5 here, becomes the first node, and the first node here becomes the last node. So how can we do this? So let's take a look at an example here. Let's say we have a linked list with 3 nodes, 1, 2, and 3, and 3 is pointing, the next of 3 is pointing to null. So let me just go ahead and make a copy of this list here. So all we can do is we can create a second pointer called todo. And this pointer is basically the next node that we're going to sort. Um, and we're going to go into a loop that keeps taking the to-do node and move that to the front of the list. So what we're going to do is we're going to move to-do to next element here, and we're going to take this one, we're going to move it to the front, like so. And we're just going to keep doing that. Um, So the next node is 3. So we're going to do the same thing. Move to-do to the next node, which in this case is the end of the list. And we're going to do the same thing here and move this element to the front of the current list. And here we see that to-do is pointing to null. That means we're done. So that's the basic idea of the algorithm. So let's go back to the code, and we'll write the code for it. So here we check some basic cases. For example, if head is null, or if there's only one node in the list, we'll just return head. So if head is null, or head on next is null, then we just return head. Okay. And then we're gonna go ahead and create a second pointer, the to-do pointer. Let's say let to-do is equal to head.next. And we're going to set the next pointer of the head to null. Okay, and then we're going to have a while loop. And this one loops until to do is null. So while to do is not null, we're going to go ahead and create a temp pointer that points to do.next. And then we're going to set to do dot next is equal to head. Set head is equal to do, and set to do equals temp. And here we're basically done, and we'll just return head. Okay, so let's go ahead and check the code. gonna go ahead and run it. And so all the test cases pass. So let's go ahead and submit. And you can see that's accepted. Okay, so let's talk about um, the complexity of this algorithm. So what is the time complexity of this algorithm? Um, so basically we have a loop here that loops through all the nodes in the list. So the time complexity of this algorithm is O of n. What about the space complexity of this algorithm? So we really only have basically like 2 pointers here. So to do is a new pointer, and then temp is another pointer. So we don't really have any other variables. So the space complexity of this algorithm is O of 1. So I hope you find this explanation helpful. And if you do, please like and subscribe the video. And I'll see you at the next video.